Good morning, everyone. I welcome you to this talk series CS Katha Barta, where we invite academics and professionals to deliver their talks. Our guest for today's talk is Professor Animesh Mukherjee. Professor Mukherjee is a full professor in Department of Computer Science and Engineering, IIT Kharagpur. He is also a distinguished member of ACM. His main research interests center around the content governance, which includes content moderation, content dissemination, content maintenance. He regularly publishes in top CS conferences, including AAAI, HCI, ACL, EMNLP, and so on. He has received many notable awards and fellowships, including the Facebook Ethics for AI Research Award, Google Course Award for the course AI and Ethics, IBM Faculty Award, Humboldt Fellowship for Experienced Researchers, Simon's Associateship, ICTP, to name a few. Today, he will be speaking about vulnerabilities of LLMs in hate speech detection. Welcome, Professor Mukherjee, and I invite you to take the virtual stage and begin your presentation.
Thank you very much. So, I was looking at the website that you are maintaining on CS Katha Barta, and I found it really interesting. So, I see a lot of people have given like very good talks. I mean, talks on very good and interesting and cutting edge topics. I mean, congratulations to all of you, and thanks for inviting me to this meeting. So today I am going to present a work that was recently accepted in the findings of EMNLP. And with that, I'll be presenting a little bit of unpublished work, but I think it's okay to record the same. So before I start off, uh, like um, I would start with a question to my audience. So please answer in yes or no, or like by some +1 or -1 on the chat box as to how many of you have heard the term LLM. Rucha, may I request you to count and tell me because I'm not able to.
Yes. So,
Tell me if there is any
yeah.
no's.
Yes, there are a few. I saw four no's, but many of them are yes.
Okay, so to those that have responded in no's, now I try to rephrase the question and ask you, how many of you do not know ChatGPT? Is there any no?
No.
Okay, that's good to know. So, so for short, ChatGPT is an LLM or a large language model. Okay, so these large language models have been shown to have fantastic powers. In fact, some people still believe that they have magical powers. Okay, so and these are mostly like advanced deep learning models where the basic architecture is based on a transformer model. And like I am not going to go into the details of this, but then this transformer model mostly works on attention spans on different words in a text, and from that it tries to learn various contextual information about the text it is processing, and that gives it like this extraordinary power that we keep on talking about LLMs or chat GPTs, like which is more commonplace. So but then like these LLMs are now being used everywhere. Sometimes it is used with proper precautionary measures, and sometimes it is just used in the wild without proper testing. So we wanted to see that how do LLMs fare in a very important task which has a lot of societal value, and which is like very much tied to incidents in the offline world, as we will see, or in the in-person world, physical world, as we will see, uh, which is hate speech detection. So, what is this problem all about, and how are we going to use LLMs to detect them? And in the process of detection, so we will try to see that whether LLMs are really worth in detecting hate speech on in the online world, and if they are, then to what extent, and what are the vulnerabilities, what are the problems that LLMs typically face when they are tasked with this kind of a problem like hate speech detection. So that is more or less the summary of the presentation. Now let's go into the uh, details a bit. So I guess like most of you in the audience are aware of what hate speech is. Like it's a defamatory speech, um, which is usually insulting, contains abusive words, and is typically targeted toward an individual or a marginalized group. This marginalization could be based on the income scale, could be based on disability, could be based on national origin, could be based on race, gender, religion, and things like that. So, and I guess many of you have, uh, I mean, those who are frequent users of social media have come across some form or the other of hate speech. So, where there is a party who tries to post hate speech against another party. So, the party that tries to post hate speech or malign um, someone are called the perpetrators, whereas the party which are attacked are called um, targets or victims. Okay, so here uh, you see some real life as well as some the so-called uh, mental effects of hate speech that is going around in the online world these days. So, and lot of works have shown that this is only at an this is increasing at an alarming rate. Okay, the amount of hate speech and misinformation and disinformation is increasing at an alarming rate, and I guess I don't need to additionally motivate this audience about this. But then what is important to know that it's not only like contained within the online world. It has its ramifications into the physical world. Some of the examples that I show you here actually are the online world effects translating into physical violence. One among them was the Pittsburgh shooting, where the shooter was actually posting anti Semitic content on a platform called Gab, which is an alt right or a French platform, and he had been doing that for a long time, and had his posts been properly tracked and followed, probably this physical incident could have been stopped. Similarly, I guess many of you have heard about this Rohingya genocide, and this genocide has been like to a large extent propelled by uh, different posts as well as advertisements as well as videos, images that Facebook propelled over its platform without even a minimal check. Okay, so these were some of the physical consequences of the online world. Same on the other side, like if you look into the mental harassment that that an individual or a group actually goes through when they encounter hate speech on social media, targeting probably their group, their marginalized group, or maybe an individual. Maybe many of you have heard about words like cyberbullying, etc. So all of these are different forms of hate speech or abusive speech, and they actually inflict the social media like wildfire these days. So, and there has been lot of reports of suicide cases, etc., resulting from this kind of uh, uh, hateful posts that spread across the social media without much moderation. So therefore, like, we as a scientific community, uh, and precisely working in AI ML technologies, uh, had this hope of trying to detect hate speech that is spreading on the online social media. And in order to be able to detect that, we need AI algorithms, okay, AI or machine learning algorithms. But then, if these algorithms have to be efficient enough, as you know, most of the machine learning algorithms are data hungry these days, and therefore these models need to be fed with a lot of annotated data. That is, the model need to know a large uh, like a large amount of uh, content which is manually annotated or annotated by humans as being hateful or not hateful, so that it is then so that the amount of misclassification that the model does is reduced, okay, because there are implications of the misclassification. So if you like misclassify a, a hateful content as non-hateful, then what happens is that you allow the hateful content to spread over the internet, and that has a lot of repercussions. On the other hand, if you stop something that is not hateful, but if your model believes that it is hateful, and you stop or disallow the post of that particular content, or even go further and suspend the account of the person, then that could have lot of like reverse ramifications. For instance, this actually curtails or curbs the so-called freedom of speech, or the fun, which is one of the fundamental rights that is like prevalent across most of the countries of the world. So so there are these challenges, so you need a lot of annotated data. So people started thinking that once chat gpt like machines became available, people started thinking like, since this is a very important and significant societal problem, can somehow uh, LLMs, or like for that matter, ChatGPT and its family, be used as an alternative to do hate speech detection, because these models have already seen a huge volume of data across the internet. Okay, and therefore it is expected that it has also learned in the process of seeing so much data what is hate speech and what is not hate speech. So therefore the requirement of having a large volume of human annotated data is mitigated. Okay, so that was the main reason why we, as well as some of our colleagues across the world, started investigating the power of LLMs in detecting hate speech as soon as it is posted on the online platform. Suppose today Facebook or Twitter or some other social media platform comes up and says that, oh, hey, I'm going to use ChatGPT to detect something which is hateful and something which is not. Or say even Facebook can use its own LLM. Anyone knows what is the name of the recent LLM introduced by Facebook? You can type it on the chat window. So Facebook. So I guess many of you are aware that most of the top companies actually are building their own LLMs, or like Chat GPT counterparts. So Facebook also has one of its own.
Llama 2.
Llama 2. Yeah. So earlier it was Llama 1, now it's Llama 2. Yeah, so suppose one fine day the Facebook boss comes in and thinks that, okay, I will use llama 2 to detect hateful content on my platform, and accordingly I will flag something as hateful and maybe suspend the account, or ban the account for for 24 hours or something like that, and that should solve most of my problems. So this hope or this wishful thinking is needs to be audited, or needs to be checked, needs to be verified whether the LLMs really have that power to actually detect hate speech with good amount of accuracy. So that is what we are going to see in this work. So uh, in order to make LLMs work, what we need is to give them some instructions. Okay, these instructions are usually termed as prompts. So those of you who have used ChatGPT would know that you ask the system to solve some task using a set of instructions that you feed it to them, and or feed it to the system, and you expect a desired response. Okay, so therefore we thought that why not ask this simple question to ChatGPT. Given a piece of text which we know from beforehand that it is hateful, we ask the ChatGPT model, okay, tell me, do you think that this is hateful or not? So we just prepare some simple instructions and their variants to identify whether ChatGPT or its like related counterparts are able to discern whether the post or the text that we are typing or the instruction that we are giving, which includes the hateful post, is really hateful or not. So basically, this is what we wanted to check. So in order to do this, what we did was we tried to craft prompts, as I said, and employ the LLMs to detect something that is hateful or toxic or abusive. Okay, in a zero shot setting. What does zero shot setting mean? Zero shot setting means that we do not give any additional data to the LLM, any additional annotated data to the LLM, so that it knows like what is hateful, what is toxic, what is abusive, so that it has the opportunity to learn. So we do not give any data to the LLMs to additionally learn anything. Okay, and then we compare the performance of the different proprietary and open source LLMs, and then we automatically identify certain data points to which the LLMs seem to be very vulnerable. Okay, these are actually called prompt injections. So this idea of identifying some data points to which the LLMs are really vulnerable and do miserably poorly are called the jailbreaks of LLMs, okay, or prompt injection attacks on LLMs. So basically, as if LLM has a guardrail and you have some examples which are able to bypass those guardrails. Okay, and as soon as you are able to bypass those guardrails, you are thought to have jailbreaked the LLM. So that's how like you can literally interpret things. So the overall workflow of the system is like this. So we have an instruction which is like the prompt, and then we have some hate speech taken from hate speech data points taken from some very standard data sources, and then we pass it to the LLM and ask it for its opinion whether it finds the text or the piece of text to be hateful or not hateful. Okay, then we identify those cases where the LLM actually misclassifies the data, that is something that is really hateful known from its human annotations is classified as non-hateful, and the vice versa. Okay, so those misclassified data points, as well as we ask the LLM that can you explain why you uh, identified something as hateful. So if this explanation is poor, we will see how we judge whether an explanation is poor or not. So if this explanation is poor and the misclassification is there, then we have good enough confidence that the LLM is going wrong and it does not have a clue why it is going wrong. So these are the points which are kind of the jailbreak points or the injection attack points. So we collect them and we try to find out like what are there any specialities of these data points? Why are the LLMs failing? Why are there guardrails breaking for these special set of data points? Can we find out some patterns in these data points? So this is the overall pipeline that we are going to see in the rest of the talk. So in order to do our experiments, we took three very well-known data sets. So the first one was mm, based on um, a, a data set that was taken from Reddit, and it has Reddit and Twitter. I think it's a mix of Reddit and Twitter, and um, it has two types of hateful content in it. One, which is explicit, where you see very blatantly used, very blatantly used hateful terms against particular communities, okay, particular religious and racial communities. While there are others which are only implicitly hateful. That is, just by reading the text, it is difficult for anyone to understand the inner context. Okay. So, but then when you tease it apart, you find that this is a, a hate content that is targeted toward Mexicans, and this is the implied hate statement. Okay, so the annotators need to have this additional context in in their knowledge base in order to do annotations of implicit hate. So this data set has both explicit as well as implicit hateful content. The next one is the hate explained data, which was released by us in 2021. And the good part of it is that it not only contains the labels, that is, uh, whether it is hateful or not hateful, whether it is offensive or not offensive, but it also contains the target or the victim group towards which this particular hate speech has been hurled. In addition to that, the annotators also marked the positions in the text. Okay, these are what we call the explanations or the rationales. Okay, the annotators marked the positions in the text which made them feel that this is hateful. This particular post is hateful. So in each of these, the annotators, as you see, have marked the positions in the text, which is kind of acting as an explanation as to why they thought this particular post is hateful. So such kind of annotations are also present in the implicit hate dataset, as well as in the third dataset, which is like toxic spans, where again, like the annotators not only mark something, not only marks a post as offensive or toxic, but also they mark the span of the text, like the span here. Okay, the span of the text which makes them feel that this particular text is hateful. Okay, so these are the explanations that we are going to also use later. So the things that the annotators mark is what I would refer to as ground truth from now on. Okay, so therefore the label that the annotator has marked is the ground truth label. The target that the annotator has marked is the ground truth target. The rationale that the annotator has, rationale or explanation, whatever you call it, that the annotator has marked is called the ground truth explanation. So, and we will task the LLMs also to generate each of these, and then we will compare the model generated outputs with these ground truth outputs. Okay, so this should be the way of checking the performance of the model. Okay, so as I said that in order to make these LLMs work, we need to have certain instruction formats. Okay, so we have used multiple different instruction formats. The first one, as we call it, is the vanilla format, where we just ask the LLM. I'll give examples of each of these. We just ask the LLM that given this particular post, do you think it is hateful or not? Okay, the second one is, as you see, the name suggests definition. So in addition to the vanilla input, we also tell the LLM, okay, you can consider this particular definition. So we feed the LLM with a definition, a standard definition of hate speech. And tell it that consider this definition when you are giving your opinion about the post. Then we ask the LLM, whenever you are classifying something as hateful or not hateful, please explain why you are doing so. So now we could ask the LLM to do it, or we could also feed the explanation to the LLM. How can we feed the explanation to the LLM? Any guesses? So that's why there are two strategies, at output, at input. At output means I am asking the LLM, please explain why you have called some post as hateful or not hateful. At input, how do I feed the explanation, or from where do I feed the explanation? So if you recall, all the data sets that I have showed have the ground truth explanations. Okay. So in this strategy, I tell the model, tell the LLM, not only the input text, but also the explanation part, okay, of the text. So these are the parts that you should focus on. Okay. So while you are making the decision, these are the parts that you should focus on. And then I ask the model to opine on whether something is hateful or not. So this is an additional clue that I am giving to the LLM. Okay. In one case, I'm asking the LLM to generate the explanation, and in the other case I'm giving the LLM this additional clue to see if this additional clue helps it to make better decisions. Okay. Then same for the target. So in one case, I ask the LLM, what is the target? What do you feel about the target of the post? Who are the victims of this post? And in the second one, I give the post as well as the victims. Okay, so as input, that consider the target to be this, and then tell us whether something is hateful or not. Okay, whether a post is hateful or not. So these are the different combinations, these are the different basic prompting strategies that we use, and then we also use certain combinations of them. So now the list of labels that uh, typically these three data sets have are as follows. In the hate explain dataset, you have a post classified as either normal or offensive or hate speech. Okay, so there are differences in offensive and hate speech. You might wonder why these are two different classes. Offensive means that it will definitely contain some offensive word. Hate speech could be sentences where there is absolutely no abusive or offensive word in it, but still it could be hateful. Okay, I showed you the example of implicit hate speech already in the implicit hate data set. Even like there could be other forms of hate speech where you don't see any uh, explicit use of offensive words, but still the statement is hateful. Okay, in the implicit hate data set, the labels are explicit hate, implicit hate, or not hate. And in the toxic spans data set, the labels are toxic or non-toxic. So depending on the data set, when I ask the LLM, I will ask, okay, this is a data point from hate explain. Please tell me whether you think it to be normal, offensive, or hate speech. Okay. Second variant, I also give you the definition. Now tell me whether it is normal, offensive, or hate speech. So as if I'm increasing the number of clues to the LLM and expecting it to generate better results. But then we will see like whether adding these additional clues really enhances the performance of the LLMs or not. So these are the vanilla prompts, as I said. So I ask the LLM to classify a given post into one of the labels out of the list of labels. And the prompt template is something like this. Classify the post delimited by three backticks as list of labels. Provide the answer as either list of labels only. Okay, and then I give the example input post. Now the LLM looks into the list of labels and the post and then makes a decision as to whether this post is hateful or not. Okay, so this is the vanilla prompt. Similarly, we have the definition prompt. So here we also provide the list of definitions. So what is the definition of offensive speech? What is the definition of hate speech, for instance, in the hate explained dataset? Similarly, what is the definition of implicit hate speech? What is the definition of explicit hate speech in the implicit hate dataset? Similarly, what is the definition of toxic data points in the toxic spans dataset? Okay, so this additional clue, you see an additional clue is getting added. Consider the following definitions, and then you have the same vanilla instruction repeated. Okay, then you have the two cases of explanations at input and explanations at output. So basically, again, you see you have a very similar structure at as the vanilla prompt, but in addition, you also ask the system to generate an explanation account. The explanation for why a post should be considered as a particular label, okay, either hateful or offensive or whatever it is, depending on the data set. Similarly, for the explanation as output, here we are asking that you not only generate the list of labels for the input type, for the input post, but also give me an explanation in the format desired. So we have prescribed a format in which the explanation should be given by the LLM. So one is where we are giving the explanation to the LLM and asking only for the list of labels. Second is we are giving only the post and asking the LLM to generate both the list of labels as well as the explanation. Similarly, for targets and victims, you have two cases. In one case, you are giving the LLM the uh, text, the input text, as well as the target community, and asking for the labels only. And in the other case, you are asking both for the labels and the target community from the LLM, given the input post. And then we had different combinations, as I said. So we had the combination of definition and explanation as input, definition and explanation as output, definition and target as input, definition and target as out. So we added definition to all of these to see like whether, so if we like, uh, incrementally add on additional clues, whether this enhances the performance of the output. So now the question is, what LLMs do we investigate? So we investigated the GPT 3.5 Turbo, which is nothing but the Chat GPT. Okay, the uh, more formal name for Chat GPT is GPT 3.5 Turbo. Then we had the previous version of GPT 3.5, which is Text Da Vinci. So this is GPT 3, which was optimized on code completion tasks. And then we also used an open source. So the first two are actually proprietary LLMs. So both of these are owned by OpenAI, and you don't get to see like the inner workings of the model. This is not known to us. What exact algorithms these two systems follow actually are not known to us. So that's why they are quote unquote black box algorithms. Okay, whereas Flan T5 large is an open source algorithm or a white box algorithm, and we wanted to so choosing the two different types had a motivation. So we wanted to see like how do the proprietary algorithms compare with the open source algorithms. Okay, because many a times most of the companies tend to rely on proprietary algorithms because they feel that it is tried and tested, and it would be more robust. So we wanted to test this hypothesis whether it's really more robust and things like that. So in order to evaluate the model, so now we have got all the predictions from these different LLMs. Now in order to evaluate the model, we had two different types of metrics. One are the standard performance metrics like accuracy, precision, recall, macro F1. So these are the standard performance metrics that you usually use to assess the performance of any machine learning application. Whereas we had this additional explainability metric, which is like when we ask the model to generate an explanation, we compare this explanation with the ground truth explanation, because recall that all these three data sets had ground truth explanations marked by the annotators. Okay, so we had this liberty of generating the output explanations and comparing them with the ground truth explanations to see how good the explanations generated by the LLMs are. So do they match with the human explanations or not? So that was what was the question that we wanted to ask. So to our slight surprise, what we saw is that for the heat explained dataset, the best prompt combination is the vanilla plus definition plus target. So basically you have the text content or the input data point or the hate speech data point, you have the definition, and you have the target information at input. Okay, so target at input. So this is the best prompt combination where the LLM reaches a performance of slightly more than 60%. And the more surprising part is that the open source LLM actually does better than the proprietary LLMs. Okay, Flanty 5 actually does better or outperforms both GPT 3.5 and DaVinci. So, but let me halt for a while and ask you whether, what do you think, like, is uh, say 61-62% or 61-62% macro f1, is this a good number or a bad number for a classification task? So for hate explain, it's a 3-class classification. So either it's normal or it's offensive or it's hateful. Okay, what do you think? What is the take of the audience? Is it good, bad, worse, excellent? So based on this performance, I have to judge, right, whether I should be deploying this LLM for identifying something as hateful or not in the online world. Okay, I want to replace a human being. I want to replace a human moderator by this LLM, as if this is like a working like a robot for me. So with 61% accuracy, should I do the deployment? No votes?
There are no's in the chat.
Ah, okay, very good, very good. So 61% is really not a good number. So we are not really there. So although there is so much of hype with LLMs being used at in different areas of, like, applications, so for this particular societal problem, it still seems that we are far beyond the expected level of performance. So uh, similar things are observed for the other data sets. So when we look into the implicit hate, actually DaVinci works better. Okay, the best prompt combination is again vanilla plus target at input, and the best model for this is DaVinci, which you see is an earlier version of ChatGPT. So this should raise a question in our mind. So an earlier version model is actually doing better than a later version of model. So is there something going wrong somewhere? Okay, and if so, what is going wrong? Okay, this is a question that immediately struck us when we saw these results. Of course, Flanty 5 also maintains a good performance compared to the other two models, except for this particular combination where we see that DaVinci actually outperforms the other two schemes. Okay, and there is a interesting connection between the previous prompting strategy and this prompting strategy. So in both cases, what we see is that the target at input is playing a very important role. Okay, so if you specify the target at input, then it becomes slightly easier for the model to detect whether something is hateful or not. Okay, So the third one, the toxic span dataset, again we see that Flanty 5 actually emerges as the best model out of the three. And here, uh, the explanation at input is actually helping the model to learn the best patterns. And in particular, you see in this data set, the performances are better compared to the other two data sets. Okay, so the first data set had three labels, the second data set had again three labels: implicit, explicit, and non-hate. And the differentiation between implicit and explicit is really hard, so we will see some examples of that when we do error analysis. This data set is actually a binary data set. Okay, here you have only toxic and non-toxic, and therefore the models seem to perform way better in this particular setting. Okay, so the moment the number of labels actually increase from 2 to 3, these LLMs actually seem to fall beyond the expected level of performance, which we could like ballpark at say 80% or something at least. Okay, so and here uh, the other thing to point out is like the explanation as input is doing well, or is helping the model to uh, get uh, to the uh, ground truth labels in the most efficient way. Okay, so some misclassifications that we tracked immediately after we got these results were the following. So in GPT 3.5, when we look at the implicit hate data set, so what we saw is that many of the non-hate data points actually are classified as implicit hate. Similarly, many of the implicit hate data points are classified as explicit hate by the Da Vinci model. And for the Flanty 5 model, implicit hate are like um, at some points predicted as non-hate, and at some points predicted as explicit hate. So out of this, what do we learn? So looking at the implicit hate data set, what do we learn? What is the most confounding thing for these models? So the models seem to get confused between what is explicit and implicit and what is non-hate and implicit. So these are the two major points of confusion for this particular data set. For hate explain, what we see is that most of the times the normal or hateful content are mispredicted as offensive for all the three models. Okay, so in fact, Flanty 5 has a reverse trend, so where the offensive and hate is mispredicted as normal. But you see, like either it is this way to that or that way to this. And for the toxic span data set, many of the non-toxic data points are marked as toxic by all the three models. So from all these three sets of errors, we come to one very interesting point. Who can guess? The clue is, look at the toxic span results. This should give you a clue. This is hidden in the other two also, but maybe it's written in a little more cluttered way, so that's why it's not featuring out. So what does this say? So all those low performance that you observed is because that for most of these models, they are over apprehensive or they over trigger. So in apprehension that they might miss something as toxic, they trigger like majority of things to be toxic. Okay, so it's like something is non-toxic, but I feel okay, it's toxic, let me put it as toxic. I don't want to be, blamed later. So that's the kind of a feature that is coming up from the model predictions. So whenever, so you see in the previous one also, in the hate explain also, normal is classified as offensive. Again here normal is classified as offensive. So again here non-hate is classified as implicit hate. Okay, so these, many of these, or a majority of these errors actually pertain to this over triggering of the LLMs, and this is more true for the commercial LLMs, okay, as we will see later. So when we do the typology study. So therefore, these LLMs actually try to be extremely apprehensive and like flag anything, or like almost anything that has like the minimum most, you know, uh, negative content in it as hateful, so that like later on people could not come and blame them. Okay, so now, as I said earlier, that we wanted to identify all these misclassified cases and improperly explained or less properly explained cases. So what we did was we jotted down all the data points from across all these models which were misclassified. And then we looked into the explanations produced by the model for the, or the reason produced by the model pertaining to its classification. Now we compared these reasons with the reasons provided by our annotators, because these three data sets have these rationales marked with them. And we tried to see who are the bottomers, the bottom liners in this set, like where there is a misclassification as well as there is a very low agreement between the explanation given by the model and the explanation given by the humans. And we did a simple clustering. Okay, so this is a topic clustering, which is, I mean, very common in the NLP literature, which is like, which has been used for ages now. It's called latent dirichlet allocation, or LDA for short. So, and we set the number of topics to 3. So this actually is a tool which will give you some word clusters. Okay, and we tried to make sense of these word clusters. We appointed annotators and we tried to see what these word clusters mean. So this typology brings us to some very interesting observations. So if you look at the implicit hate data set, what we see is that in many cases, non-hate is actually misclassified as implicit hate, because there are certain terms in this post which the model feels could be sensitive. But actually, when you read this post, these terms are no way sensitive. But as I say, the model wants to be over apprehensive. So just the mere presence of the word racist makes the model feel that these are hateful posts. And therefore, although it is in the ground truth, it is non-hateful, the model marks it as implicit hate. So this is where one case where the model goes wrong. Similarly, in some cases where the text is pro-white, okay, you see the word white is here, the word white is here, and each of this is a pro-white statement. So a pro-white statement does not need to be, hateful always. Okay, so these are all non-hateful statements, but then the model again, because of its over apprehensiveness, marks both of these posts as implicit hate. Okay, similarly the third one. So here what you see, there are certain sensitive words, okay, statement with sensitive words like intolerance, antifa, black, higher American. So these are, so black is the name of a race, which is actually a sensitive attribute in the US. Okay, because it is thought to be that the African Americans are a marginalized group in their society. So therefore, like these sensitive words, although they are benign, they do not have any additional implication on the statement or on the input post. They are just their mere presence makes the model feel that these are hateful statements, and therefore it misclassifies them as implicit hate. For hate explain, again, what you see that the moment there is a negation, okay, so you see neither feminism, the moment there is a negation, the model starts believing, okay, so it's not offensive, okay. So but actually the statement, if you look carefully, is offensive, and the model mispredicts the offensive class to normal class, okay, just because it picks up the clues from the negation words, but these negation words actually do not make the statement normal, okay, it is actually offensive. But the model, so the moment you see, this is more interesting. So nigger is this is a n word, as we call it, is a word which is a slur, which is a racial slur for the African Americans, and this is a strictly banned word, at least in the common language. But then so, and it's a hateful word, therefore, and this makes the whole sentence hateful. But then since there is a negation no there, the model starts feeling complacent and thinks that, okay, so therefore since there is a no there, that means this is a non-hateful statement, and therefore I should mark it as non-hateful. So similarly, there are other cases. So you see, these are the different types that we are discovering from our analysis. So if you look, the racist is a type, pro-white is a type, sensitive words is a type, negation is a type, vocabulary gap is a type. So there are these words that seem to be not present in the vocabulary, yet not present in the vocabulary of the LLMs, and therefore each of these are marked as non-hateful or normal. Okay. Similarly, polysemous words. Polysemous words are words which have multiple meanings. Okay, a single word might have multiple meanings. Now, some of these meanings are apparent to the LLM or known to the LLM or are in the knowledge base of the LLM, whereas the other meaning, the hidden meaning, is not available. So therefore this particular word and this particular word has a hidden hateful connotation which the model is not able to understand, and therefore hateful, I mean, or like offensive connotation. So the model is not able to understand that, and it mispredicts the statement as normal. Similar is the case for toxic spans. Again, here many of the, as I showed you earlier also, in the toxic spans dataset, most of the mispredictions are from the non-toxic class to the toxic class, because the models seem to be extremely over apprehensive. Okay, and so these types are the types which are the jailbreak points, or if you can classify data points that are coming to the LLMs into one of these types, okay, other types are fine, but these types are problematic types. If a post belongs to any one or more of these types, then the LLM is vulnerable to such a post. So a jailbreak might be caused. The LLM might not be able to correctly classify the level of such posts. So that's why we did this typology induction. And this is actually a joint project with OpenAI itself. And most of these recommendations about the typology that we developed has actually now been sent back to them. And now if you like recheck ChatGPT or its other counterparts with these particular examples, or examples belonging to these typologies, other examples belonging to these typologies, then probably will not see the model failing. Okay, so now they have actually developed guardrails in order to circumvent this problem. Okay, in order to make the model more robust toward these type of labels. But then every other day the language of hate speech changes. Okay, and the perpetrators are continuously trying to jailbreak these types of LLMs so that they are able to bypass the automatic moderation of many of these online platforms. Okay, so therefore, like, the this is not the end to the research, but it's just the beginning. So how much time do I have?
Um, I mean, a few minutes maybe.
Okay,
Yeah.
so in the interest of the time, I will stop here. So this is one work. There was another work that I thought I would be presenting, but I think, like, it might be good idea to stop here and take questions. But before I do that, I wanted to thank all my students and collaborators who were involved in this project, especially Sharthak and Punnojoy, who are PhD students directly related and working on these projects and many other similar projects. So you can find more details about us if you follow Hit Alert on Twitter, or Synergy at IIT KGP, which is the lab where I come from. So this is a lab of around 7 faculty members and around 35 to 40 PhD students, PhD and master students. And like, we have a very vibrating group working on many different problems, uh, like in recent, I mean, concerning recent developments in AI and ML literature. So if you are interested, you can go and visit our websites. And like, if you want to spend a stint here, feel free to write to us, and we'll be happy to, like, either accommodate you online or in physical or in person mode. Thank you very much.
Thank you. I think somebody had a question. Aviral, you raised your hand. Aviral? Okay, it was my mistake. Fine. Um, okay, there is a question.
Mhm.
Have there been cases where a LLM hasn't been trained to produce hateful responses but produces hateful content as a consequence of emergence?
Yes, there are like, and that's why, like, people have been trying to develop more and more guardrails. Okay, so LLMs have this uh, interesting power of concept learning. So if you give the LLM a few set of examples, which we call the few shot setup, or even, like, one could have a chain of thought setup. So you make the LLM, like, go through a set of reasoning, and by way of doing very cunning reasoning, you can make the LLM actually hurl hate speech. So for instance, there have been many cases where um, the perpetrator actually interacts with the LLM, telling that he wants to have some he wants to crack some jokes about African Americans, or about Muslims, and makes the LLM believe that it's just for fun. And once the make believe is successful, then you can make the LLM spit, like, as much hateful content as you want.